Today, we're going to talk about a single idea that is honestly a secret weapon for making smarter decisions, whether you're a doctor, an engineer, or just, trying to figure out if you should grab an umbrella. It's called conditional probability, and it's all about how to get better at changing your mind when the world gives you new clues. And to really see just how powerful this idea is, let's just dive right into a puzzle. One that, well, it might just trip up your intuition a little bit. So picture this. You're in a super high-tech factory. An alarm, one specifically designed to catch defective microchips, starts blaring. The system flags one single chip. So what's your gut tell you? What are the odds that this chip is actually faulty? Now, I bet most of us would immediately think the chance is really high, right? Like 80, maybe 90%. I mean, the alarm went off. But what if I told you that our gut feeling here is way, way off the mark? The actual probability is just 40%. Yep, you heard that right. Even when the alarm designed to catch these things goes off, there's a 60% chance the chip is totally fine. So how on earth is that possible? To figure this out, we don't just need more information, we need a completely new way to think about it. So, the key to solving our little mystery here lies in understanding how new information doesn't just add to what we know, it fundamentally changes the odds by shrinking the entire world of possibilities. Let's make this super simple. If I ask you, what's the chance of rain today? You might check a forecast and say, maybe 30%. But what if I add a new piece of information? What if I say, okay, what's the chance of rain today, given that you can look outside and see the sky is dark and you're hearing thunder? Instantly, your brain updates the odds. It's got to be much higher, right? And that simple update is the entire core of conditional probability. So formally, all we're doing is putting a name on this process. It's the math of updating our beliefs. And that notation you see, P of A given B, I know it looks a little intimidating, but it just means what's the probability of event A happening given that we already know for a fact that event B has happened. And here's the absolute key takeaway. Once we know that event B has occurred, our entire universe of possibilities just shrinks. We're not looking at every possible outcome anymore. We're now living only in the world where B is a fact. Statisticians call this the reduced sample space. And honestly, it's the secret to everything we're talking about. Okay, so let's take this logic and turn it into an actual tool we can use. There's a simple but incredibly powerful formula that's going to let us solve that factory alarm puzzle once and for all. Now, before I even show you the math, the logic is really, really straightforward. First, you just figure out the chance of both things happening together, the event A and our condition B. Then, you find the chance of just the condition, B, happening all by itself. And finally, you just divide that first number by the second. That is literally it. And here it is. This formula, it's just a fancy shorthand for the exact 3 steps we just walked through. The probability of A given B is just the chance of A and B happening, divided by the chance of B happening at all. Looks formal, I know, but it's just the same simple logic we already get. Okay, we are now officially armed and dangerous. We've got our new tool. Let's head back to that factory floor and finally figure out why that alarm is so misleading. All right, here's the crucial info we were missing before. First, turns out defective chips are actually pretty rare. Only 5% of all chips are faulty. Second, the alarm goes off 10% of the time, for any reason. Maybe it's just a little twitchy. And finally, the chance of both things happening together, a chip being defective and the alarm going off for it, is 4%. So, let's frame our question using our new language. We want to find the probability that a chip is defective, or D, given that we know for a fact the alarm, A, has sounded. In our notation, what is P of D given A? And now we just plug in the numbers from our table. The probability of a defective chip and the alarm is 0.04. We divide that by the overall probability of our given condition, the alarm going off, which is 0.10. And there it is. 0.04 divided by 0.10 equals 0.4, or 40%. Mystery solved. See, the reason our intuition was so wrong is that defective chips are rare, but the alarm is kind of noisy. It rings a lot, creating false positives. It goes off way more often than there are actual defective chips to find. So now that we've cracked the case, let's zoom out for a second and see how this one simple idea is quietly running the world all around us every single day. Let's use another quick analogy. Imagine a college has 1,000 students.
and 100 of them play cricket. If you just pick a student at random, the probability they play cricket is 100 out of 1,000, or 10%. Simple enough, right?
But what if I add a condition? Let's say we know the student we picked is a boy. And if there are 500 boys total and 80 of them play cricket, our world just shrank in half. We're not looking at 1,000 students anymore. We're only looking at the 500 boys. So the new probability is 80 out of 500, or 16%. The odds changed because our world got smaller. And this exact logic is the engine behind so much of the technology we use every day. Your spam filter, it's calculating the probability an email is junk, given it contains the word lottery. Recommendation engines are guessing what you'll watch, given what you've already watched. It is, and I mean this, absolutely everywhere.
But this brings us to the single most important warning. You have to be so careful not to confuse the direction of the probability. Getting this wrong is one of the most common and, frankly, dangerous statistical traps out there, especially when it comes to things like our health. Think about it like this. The probability that you'll have a fever given you have the flu is super high, right? Maybe 99%. But the reverse, the probability that you have the flu given you have a fever, that could actually be very low. Why? Well, because lots of things cause fevers, but the flu is hopefully a lot more rare. Confusing those two is a huge, huge mistake.
So, we'll leave you with this question to chew on. As you go about your day, think about the assumptions and predictions you're making, and ask yourself, where might a single new piece of information, a new condition, cause you to shrink your world of possibilities, and maybe, just maybe, completely change your mind?